Welcome to the Math Record. In the third part of the ICTM Regional 2018 Division AA Geometry, I'll be covering questions 15, 16, and 20. Okay, let's begin with 15. An equilateral triangle is inscribed in the square, so basically just this picture, and S is the side of the square. Then the area of the triangle is ks squared. Determine the exact value of k. So we have some kind of diagram. So we have, let's say, some kind of square, and then we have some kind of equilateral triangle like this. Okay, that looks fine. It's okay. And then basically, we know that this is 60 degrees, right? And this is 90, right? And these should be equal lengths. So 90 minus 60 is 30. 30 divided by 2 is 15. So that gives us that each of these are 15. And these are 90 degrees. So this means this is 75 and this is 75. And these are 60. So this should be 45. Or another way you could think about it is these two lengths should be equal, logically. So then technically, then these had to be 45, which also makes sense because when you put these 75 plus 60 plus 45, that's equal to 180. Okay, so if we label, so we know that the side length of the square is s. So if we label this length is equal to a, and this length is equal to a, then this length is s minus a. Okay, and this is a special right triangle, the 45, 45, 90. If this is A, then this is going to be A times square root 2. Okay, and this is also a special right triangle. If you don't know the 17, the 15, 75, 90, basically opposite of the 15 is square root 6 minus square root 2. Opposite of the 75 is square root 6 plus square root 2. And opposite of the hypotenuse, and the hypotenuse is 4. So to get from s minus a to the hypotenuse, we gotta get from 6 square root 2 to 4. So we just need to do a ratio. So basically all we had to do is have 4 over square root 6 minus square root 2, then multiplied by s minus a. Since this is an equilateral triangle, that tells us that a square root 2 is equal to 4 times equals to 4 divided by square root 6 minus square root 2 times s minus a, right? And then basically we just need to rationalize the denominator first. So that's square root 6 plus square root 2, square root 6 plus square root 2, multiply to the numerator and denominator. 6 times 6 is 6, square root 2 times square root 2 is 2, so 6 minus 2 is 4, so this number cancels with these two. And then we just have a square root 2 is equal to square root 6 plus square root 2 times s minus a. And then we could divide both sides by square root 2. So then we have a equals square root 3 plus 1 times s minus a. So then when we have when we move this a to this side, we have a square root 3 plus a 1 plus this one. So this would be square root 3 plus 2 times a is equal to square root 3 plus 1 times s. And now we need to find the s a in terms of s, because then we could substitute it in here to get our side length. So we have a is equal to square root 3 plus 1 over square root 3 plus 2 times s. And then to simplify this, we just need to multiply the top and bottom by negative square root 3 plus 2, negative square root 3 plus 2. Okay, so this is negative square root 3, and then that's 4. So that's a 1 on the bottom, so that cancels out really nicely. And then square root 3 times square root 3, that's negative square root 3, that's negative 3. And then positive 2 square root 3 and negative square root 3, that's a positive square root 3. And then a 2 and a 1 makes a 2, plus this negative 3 is negative 1, so that's negative 1 plus square root 3 times s is equal to our a. So we just did all of that just so we could find our a in terms of s. And now we could plug this into our side length, because our side length is a square root 2. So plug in this into here. So now we have square root 3 minus 1, I just rearranged it, times your square root 2 times your s. So then we have square root 6. Well, actually, I'm going to leave it as square root 2 first. Square root 2, square root 3 minus 1s is going to be our side length. And to get the area of an equilateral triangle with a side length, let's say x, right? It's going to be x squared square root 3 over 4. So x is our side length, so you could just plug in this value into our x. So then this would be 2, and then 3 squared plus 1 squared, that's 4, and then minus 2 square root 3 times s squared times square root 3 over 4. And then the 2 in here cancel each other to make a 2, cancel out this 2 to make this a 2 and a 1. So then we have 2 minus square root 3 s squared times the square root 3. So then 2 times square root 3 is 2 square root 3, and square root 3 times 3 times square root 3 is 3. So our coefficient in front of our x squared is 2 square root 3 minus 3. And that's our answer for number 15. Okay, number 16. Evie and Xavier have agreed to meet at a mall between 1:30 p.m. and 2:45 p.m. Evie will wait at most 15 minutes for Xavier to show up, and Xavier will wait at most 7 minutes for Evie to show up. Determine the probability that they will actually meet at the mall tomorrow. So what we could do is we can make a chart, or like basically a graph. So we have an x-axis and a y-axis. And then let's say our x-axis is Evie, right? So the time that Evie comes. And the y-axis is the time Xavier comes. So we could keep track of what's happening. Actually, let's move Evie a little bit down. So then we could put some points later. And then I'm going to put a line that cuts this square in half. And I'll explain why. So this line is equal to y equals x, right, as our equation. So think about x and y axes, but now I just have a square. So the reason is because if we have, let's say this point right here is 2020, right, in 20 minutes and 20 minutes, that means Xavier and Evie came at the same time, right? So on this line, Xavier and Evie came at the same time. So anything above or below is either one of them came earlier than the other. So let's say this one is 2040. And since X is Evie, if Evie comes 20 minutes later and Xavier comes 40 minutes later, that means Xavier was later than Evie. That tells us that if Evie comes first, Evie will only wait for 15 minutes for Xavier. So, or if Xavier comes first, right? Let's say this point is 2010, right? Evie comes 20 minutes later, Xavier comes 10 minutes later, then it basically tells us that Xavier came first and he will only wait for 7 minutes for Evie. So how we could think about this is that the top part is Evie comes first, and then bottom part is Xavier comes first. So if Evie comes first, right, she will wait 15 minutes. So at every single point, she will wait 15 minutes, right, etc. And that goes for every single point, right, etc. And then basically, what is the area that's made by all these points? Well, you could think about this as just another line that's connecting the tips of those 15 minutes. Okay, so let's erase that. And we have a line, let's say like this. And this is 15 minutes above. So this line is y equals x plus 15. So this length over here is 15, and this length over here is also 15. Okay. So actually, let's label our boundaries first now. So let's say the time at 1:30 p.m. is 0 minutes. So from 1:30 to 2:45, that's 75 minutes. So let's label this as 75 and 75. Okay, so now we know our boundaries. And now let's find Xavier's time. So for Evie, we were moving from down to up, right? Because that means Evie's time stay the same, but Xavier's time could increase because he has the amount of time that he can move through. So if Xavier is the one that rides, his time has to stay the same. So instead of going up, he's actually going this way. And then Evie's time could increase because she has the amount of time to move. So move something like this, right? And then he has 7 minutes, and Xavier waits for 7 minutes. So now his line is something like this. And this would be y is equal to x minus 7. So this length is 7, and this length is also 7. And now we just need to find the area between it. So we need to find this area. So a way to do that is you just get the area of the entire square subtracted by the two triangles. So what's the area of the two triangles? Well, for this triangle, that's 15 to 75. That means this length is 60. 15 to 75, that length is 60. So 60 times 60 is 60 squared divided by 2 is the area of this triangle. Now 70 to 75, that's a length of 68. 7 to 75, that's a 68. So 68 times 68 squared divided by 2, that's the area of this triangle. Now, to get the area of this, we just have 75 times 75, that's the area of our square, minus the area of our triangles, which is 60 squared over 2, plus 68 squared over 2, and then divided by our entire area, which is 75 squared, to get our probability. Because this entire thing is our entire probability. So all the points in this area is when they will meet, and all the points outside just they don't. So we have 60 squared plus 68 squared divided by 2, 75 squared minus that, and then divide by 75 squared. And we get an answer of 1,513 over 5,625. And that is our answer for number 16. Okay, and now question 20. So A, B, C, D, and E, F are parallel chords on the same line. Of the center of the circle, the distance between A, B, and C, D is equal to the distance between C, D, and E, F. So the distance between the chords are equal. AB is length 20, CD is length 16, and EF is 8. And then we need to find the radius of the circle, and then basically add the coefficients of that. So let's draw a picture and kind of like rotate it a bit so we can see what's happening. So we have a circle, and we have some kind of lines. So let's say we have a line here, and a line here. Okay, so I just rotate it by like 90 degrees clockwise to see how it looks. And we have a point of a center. And now what I'm going to do is that I'm going to make a line that starts from the center and is perpendicular to these lines. Because these are all parallel, that means if it's perpendicular to one, it's perpendicular to all of them. So that's at 90 degrees, 90 degrees, and 90 degrees. So if it's perpendicular to it, that means that we cut it in half. So that tells us that if this is length 20, then this is 10. If this is length 16, this is 8. If this is length 8, then this is 4. Okay, and they also tells us that the distance between these two chords are the same. So let's call this D and call this D. And let's label this as point A. Okay, and now we could think about this as some kind of right triangles. So we have a radius from here to here, and we have a radius from here to here, and we have a radius from here to here. So we have three separate triangles now, and they're all radius r, right? Because they're the same circle. So using the a, 10, and r, that gives us a squared plus 10 squared, which is 100, is equal to r squared. And then we have a plus d squared plus 8 squared, which is 64, is equal to r squared. And now we have a plus 2d squared plus 6 squared, which is 16, is equal to r squared. Okay, so now we don't need the picture anymore because all we need to do is just solve for this equation and find r. So we just need to solve for this. So first off, let's expand our second and third equation. So that's a squared plus 2ad plus d squared plus 64 equals r squared. And this equation is going to be a squared plus 4ad plus 4d squared plus 16 is equal to r squared. And now we're going to subtract the second and the third by the first. So then the a squared cancel each other out. So then we have 2ad d squared. 100 minus 64 minus 100 is minus 36. And then r squared minus r squared equals 0. And the a squared minus the a squared, then we have a 4ad. And then our 4d squared. 16 minus 100 is minus 84. And r squared minus r squared equals 0. And now we have these two terms. We have a times d and d squared. We don't want to save ad because these are two variables. So let's get our d squared first. So let's multiply this equation by negative 2. So negative 2 times 2ad is negative 4ad. Cancel out with this ad. And then 4ad. And then negative 2 times d squared is negative 2d squared. Plus this 4d squared is 2d squared. And then negative 2 times negative 36 is 72. 72 plus negative 84 is negative 12. And that's equal to 0. So that tells us that d, that's equals 12 on this side. 12 divided by 2 is 6. So d is equal to square root 6. And we got our length for 6. I got our length for d. And now we could just plug it back into one of these original equations. So let's say this one. And then we know that 2ad plus d squared minus 36 equals 0. And we know d equals square root 6. So square root 6 squared, that's 6. So then this is 2 square root 6 times a is equal to 6 minus 36 is minus 30. Move it to the side is 30. And then divide by 2, so that's going to be a 15. So a equals 15 divided by square root 6. And then simplify square root 6 over square root 6. So this is 6 on the bottom. Divide by a 3 to get a 2. Divide by 3 to get a 5. So a is equal to 5 square root 6 over 2. Okay, and now we could plug this back into this equation so we could get our radius. So a squared is 25 times 6, which is 150. And then 2 squared is 4 plus the 100. So that's 400 plus 150. That's 550 over 4 is equal to r squared. And square root of 150, that is 5 times 110. So 110 can also be 5 times 22. And then 4 is just 2 squared. So that's r squared. So then taking the square root, that's just 5 square root 22 over 2. Now adding the coefficients, because this is equal to our radius, that's 7 and then 22, that makes 29. And that's our answer for number 20. So basically you just need to recognize where the right triangles are. Well, that completes our ICTM Regional 2018 Division AA Geometry. Thanks for watching, and I'll see you at the next math record.